Hi everyone, welcome to this video recording. Today we are going to talk about the Gradle Build Tool 8.8 release. It was released in the beginning of June, but it took us some time to prepare everything. I was down with COVID, and as you can hear from my voice, I'm still in recovery. But we took some time, we asked contributors to record the videos, and today we are happy to present the update. We have quite a lot of major changes in this release. First of all, of course, full support for Java 22. Then we added quite a lot of improvements, including DSL, build authoring, better performance for AD integrations, etc., etc. We also reverted one of the key changes of the previous release, Groovy Build Script compilation cache. So this is what we are going to talk about today. First of all, I would like to thank all the contributors to this release. The number of contributions keeps growing, and if you want to improve something in Gradle, please submit a pull request. We're improving our review velocity, and we will appreciate all the contributions. If you want to know more about the release, please refer to Gradle release notes. There are all the features described here. We are not presenting everything today. Also, we have public roadmap with key initiatives going on, like declarative Gradle, configuration cache, isolated projects, etc., etc. And of course, subscribe to our newsletter. The new edition in July is coming out soon. There will be one in August. So we are not taking vacation, and we will keep providing nice updates. And as always, if you have any questions, please join us on the community Slack. There is a releases discussion channel where we can have all the conversation about the new features, changes, and any obstacles if you might experience them. Okay, let's continue with live demos. We'll start from major changes. Let's go.
Gradle now supports being run on Java 22. This is in addition to the compilation and testing support that we introduced in 8.7. Compatibility with some tools or languages may require separate dependency updates in your build.
So yes, now you can run all Gradle executables, including Gradle Daemon, Gradle Build Server with Java 22. For more information, please refer to the compatibility documentation we have. There is quite a lot of information, including Java, Kotlin, Groovy, Android versions, and version mapping. And yes, for Java 23, stay tuned. The alpha release is there, and we target initial support in the upcoming releases. And the next bigger change is support for JVM toolchain in Gradle daemon. So I will let Sterling Green to do overview of this feature. So thank you, Sterling.
Hi, I wanted to quickly tell you about a new feature just introduced in Gradle 8.8, daemon toolchains. For a long time, you had basically two options to control the version of the JVM the build uses. You can set Java home, or you can set a Gradle property to the absolute path of a JDK installation. Neither of these options were portable, so if someone ran your build with the wrong version, they're not likely to get a helpful message telling them that. Several releases ago, we had a feature we called JVM toolchains that solved a similar problem with controlling which version of the JDK to use to compile or test your project. We've now expanded JVM toolchains to the entire build process, so a project can declare which version of the JVM is required to run the build. In this release, the feature is limited to only finding locally installed JDKs, but the plan is to expand this to also support downloading and auto-provisioning JDKs on demand. Like the wrapper task, if your build is using the right version of the JVM today, you can capture the build's JVM requirements by just running the update daemon JVM task. If you want to use a different version of the JVM, you can also specify that on the command line. In either case, the JVM requirements are captured into a separate file that you can check in just like you would the Gradle wrapper. If you need to change the JVM requirements later, you can use the update JVM task to change this file again. This is still an incubating feature, and we plan to add more to it in the upcoming releases. We're open to any feedback you have on this. This is being developed by an external contributor that we're working closely with. So many thanks to Madeline for all of his hard work so far. Thank you.
Another big change we have is revert for Groovy Build Script compilation caching. As you probably remember, in Gradle 8.7 we introduced this feature which added all the build scripts by default. It has been actually a case for Kotlin scripting since long ago, and we did the same for Gradle. Unfortunately, it created some regressions, especially in the areas where users had a lot of smaller Groovy scripts. Each of them needed compilation, and talking to local or remote cache was actually much longer than just doing the compilation. So we decided to revert this feature, and in Gradle 8.8 this compilation is disabled. We will review our options for the next releases, so this feature is coming back in one capacity or another, but for now stay tuned. Sorry for inconvenience for anyone who was affected by this change. And the next section is Gradle Build authoring improvements. As always, we have quite a lot of changes that improve developer experience, like better DSL, and of course additional features, APIs available, and today we have overview for these features by the developers. So let's go forward.
In previous versions of Gradle, it wasn't possible to omit the version in a plugin alias in a TOML version catalog because it would throw an exception when you tried to use it. Now, it's possible to do this and it won't cause any problems.
Prior to Gradle 8.8, extensions registered in Settings plugin were not available in the settings.gradle.kts files. Today, starting with Gradle 8.8, type-safe accessors for these extensions are generated. For example, if you are registering such an extension in your Settings plugin, then you can access it directly in the settings.gradle.kts file.
And now, for something completely different, here's another feature aimed at allowing parallel configuration in a future Gradle release. The newly introduced Gradle lifecycle API comes with direct replacements for the existing Gradle before project and Gradle after project callbacks. The API is accessible via Gradle.lifecycle in Kotlin and Groovy or Gradle.getLifecycle in Java. The main difference between the new Gradle lifecycle API and the old callbacks is in how they handle this state capture by the registered actions. With the old callbacks, all state is shared without constraints. With the new callbacks, each project has its own private copy of the state. Let's see an example. In this build definition, we have a root project named root with two subprojects P1 and P2. We have a class called state to represent the state to be shared among the different callbacks. And in lines 8 and 12, the shared state is modified via the old and new before project callbacks, which in this case are simply appending the name of their target project to the shared list of project names. In lines 9 and 13, the shared list of project names is dumped to the console via the old and new after project callbacks. The build definition ends with the registration of an empty task named demo. At the bottom, we can see the output of running the demo task in quiet mode. Notice how the output for the old after project callback accumulates the name of each project as it runs, while the new Gradle lifecycle after project callback can only see one project at a time. And while the old callbacks continue to work, we strongly encourage users to migrate to the new Gradle lifecycle callbacks in preparation for the glorious future of parallel configuration.
Configurable file collections now support default values via the new convention API. So this works similarly to conventions in lazy properties. Just as it is the case with lazy properties, default values assigned via convention only kick in if no explicit value is assigned, in the case of file collections using setFrom. Finally, if a configurable file collection is extended by a build script using the from method, the convention is going to be preserved as the base value, so it's not replaced.
Last but not least, we promoted one of the incubating features, File Permissions API, to general availability. So now these APIs are fully supported, including managing permissions and accessing these permissions. So if you're interested, please navigate to Java doc that describes these APIs, and all of them are available and supported by the team now. So enjoy using them in your Gradle Build scripts. Of course, we have quite a lot of improvements to troubleshooting, including better reporting, error propagation, etc. So let's see what the team want to present today.
Here you can see an example of the new message, which will very clearly state that in order to use a certain dependency, you need to run Gradle using a higher version of the JVM. This also shows just a part of an old message. It's actually truncated here. You can see it used to contain a lot of unnecessary detail that didn't really help you solve the problem and was intimidating, to say the least. This change is especially important for users of projects like Spring Boot, which require a more recent long-term support version of Java. And when you encounter this failure, Gradle will also add a suggestion that you either upgrade your JVM or downgrade your selected version of the plugin or library. Another particularly confusing dependency resolution failure scenario occurs when Gradle encounters issues with a repository that contains dependencies. After a certain number of failures connecting to a repository, Gradle will mark that repository as disabled for the remainder of the build. If there are other repositories declared in the build, Gradle can attempt to find dependencies in them. Otherwise, if all the repositories are disabled, resolution for any remaining dependencies will fail. Here you can see an example of a previous failure message. As you can see, this message could sometimes hide important details, like why these dependencies were skipped, and what issue was encountered connecting to the repository that caused Gradle to disable it. The message could also show duplicate or irrelevant information. In Gradle 8.8, the ultimate cause of a failure should always be shown exactly once, and additional problems that result from that same cause will be omitted in order to produce briefer and more understandable failure messages. The failure message will also always include a note stating that there were some number of additional problems resulting from identical causes.
And I think that's it. Let's wrap up and talk about the next things, about IDEs. So now we have much better IDE performance, and also tooling API get a lot of additional changes.
We have an interesting performance improvement in the tooling API that affects IntelliJ IDEA, Android Studio, and more. A basic feature of the tooling API is to allow IDEs to execute tasks. In previous Gradle versions, during task execution, the Gradle daemon sent the complete task dependency information from the daemon to the IDE, including transitives. However, the transitive dependency information was discarded and recomputed on the IDE side. In collaboration with Google, we fixed the issue, but we only had anecdotal evidence about the performance gain. We suspected that large, up-to-date builds will benefit the most. Surprisingly, the scenario of running tasks in the context of an IDE was not covered in our performance test coverage. We implemented the necessary test fixtures and integration tests. We found that an up-to-date build with 15,000 tasks, which is not atypical for an Android project, for example, will get a 12% performance boost.
In previous versions of Gradle, test names reported by the tooling API were coupled with the operation display name. IDEs had to parse it for some cases, which is not reliable. In this release, we separated those names and introduced a proper method for getting test display name that provides it transparently from the underlying testing framework. This method should be used by IDEs and other tools to display a proper test name for a user. It is especially important for dynamic and parameterized tests. Also, for JUnit 5 and Spoke, we updated the test descriptor for dynamic and parameterized tests to include the information about the class name and method name containing the tests. These enhancements enable IDEs to offer improved navigation and reporting capabilities for dynamic and parameterized tests.
Then the next section is, of course, build and configuration caching. We have quite a lot of improvements there.
Prior to Gradle 8, data retention was fixed for different types of caches to either 7 or 30 days. In Gradle 8.0, we introduced a way to configure this retention period through an init script, allowing users to specify how long unused entries should stay on their machine. In Gradle 8.8, we've introduced a similar option for the local build cache, allowing users to decide how long unused entries should stay around. The cleanup option that allows you to configure how often Gradle should check the caches applies to that option as well. As a reminder, if you use the always option, that cleanup happens inside the build itself, potentially lengthening it.
We continue to improve the configuration cache feature, and in this release we added support for Java records and externalizable instances. This might be useful for build tool engineers writing tasks and plugins in Java.
Of course, we have quite a lot of other improvements in peripheral components and plugins included in the Gradle core. And I will let Tom Tresansky to present these changes.
This next feature originates in a community PR that we were able to merge for Gradle 8.8. Thanks to JHROM for contributing it. When running tests with Gradle, you may not be interested in capturing all of the output generated by the code being tested, especially on CI or in other scenarios when disk space or memory is limited. The JUnit XML report format is shared by many test frameworks, including JUnit 4, JUnit Jupyter, and TestNG. Using the two new properties that we've added to the JUnit XML extension that's shown below, you can control whether or not to capture output in these XML files. This feature is another that originated in a community PR, thanks to Stefan M. for contributing it. It used to be the case that a custom POM declaration via the publishing.publication block would be either ignored in favor of the display name and description properties set in the Gradle plugin.plugins block, or entirely omitted from the generated POM. Now the values set in the publication block will always be used if present and written to the POM file.
Okay, that's it for today. So we have quite a lot of other improvements like documentation, new community portal, Gradle cookbook. We'll share more information about it in the next release video. And for today, I would like to thank everyone who watched this video. Thanks to all contributors, thanks to maintainers and team members who actually recorded the videos for today. If you want to learn more, we have release notes which are published, which provide upgrade guidelines and all the information about the changes we presented today. You can also see previous demo videos on our YouTube channel. There is a public roadmap that describes key initiatives, and as I mentioned before, there is a newsletter with all the updates. If you want to learn more, follow our community Slack, join us there. There is a releases discussion channel where you can ask any questions about the changes presented today. There are also quite a lot of respective channels like Android support, declarative Gradle, which you can also use. So see you on these community resources and have a great summer. Bye.